Hello guys, welcome back to our YouTube again with another video. Today I'm going to explain you how the flow of electrons from where to where, and what is a conventional current flow, and what is the practical and real life applications of electron flow, and what is the difference between conventional current flow and real life current flow, electron current flow. So let's have a look at it here in this video. So let's start the video. So here see, this is C amplifier. No, C characteristics circuit. This is common. Emitter is common. So here arrow indicates the flow of positive charges. B indicates this is an NPN transistor. NPN transistor. So in conventional current flow indicates that the positive charges are charge carriers. So here it is not true in real life case, because electrons are the charge carriers in the real life, because they are the smallest particles in the universe. So electrons are called to be as uh, charge carriers, because they are minute, and they are invisible, and they are the smallest particles which we can know uply. So here this is all about characteristics. So here I will explain graph clearly. So here is the current flow from here, negative to negative. In this way the current will flow from here. So this is negative here. So it is negative. B is forward bias, because here negative is connected to negative and positive is connected to positive, and positive is more positive than negative, so it is forward bias. Positive is more positive than negative. Then negative it is said to be as forward biased. Said to be as forward biased. Reverse biased means what here? Reverse biased means negative is more positive than positive. So it is the converse of the statement of forward bias. So here see, from here electrons are flowing like this. So here it is came from here to here. So here positive charge converted to negative charge. So the circle indicates that only. The positive charge changes to negative charge. And here negative charge converts to the positive charge here. Because here from negative charge, this is negative, n-type conductor, n-type transistor. It is end part of the transistor. So from here electrons move from negative to positive of the positive terminal of the RPS. So here what happens here, this will go in this way, electrons will go in this way, but the current flow will be taken as in this way, because for conventional current flow is the opposite to the real life flow of electrons. Conventional current flow states that positive charges are charge carriers, but it's not real in the real life case, because positive means protons are heavy in nature than electrons. So how can they be charge carriers? If the lightweight is there, there will be more movement of electrons. If you are so fat, how you can move easily? If you are thin, you can move easily. So that's the difference between electron and proton. I am using an easy analogy to make you understand very well. So here is the explanation. So here positive is connected to negative, and negative is connected to collector positive. So it is in reverse bias. So BC, base collector junction, is reverse biased here. That we can understand from this diagram. So I'll explain how is the electron flow in this circuit. I will explain in this video. So let's have a look at it here. So this is a common collector characteristics diagram, circuit diagram. So it is a RPS 0 to 30 volts plus minus. So here also see here uh, base base BC junction to be reverse biased. Reverse biased means what here? Reverse biased means positive is more negative and negative is more positive. See here, positive means this. This is more negative here, and negative is more positive here. So this is said to be as forward bias. So this is said to be as forward bias. This is said to be as reverse bias. What is reverse bias? If the positive junction is more negative than negative junction, it is said to be as reverse bias. So BC junction is reverse bias. So it acts in the active region. And also here see the electrons will moving. Here see positive terminal is connected to emit base positive, and negative terminal of the RPS is connected to emitter negative. So here see positive is more positive than negative. Positive is more positive than negatives negative. So here it is set to bias in forward bias. B is in forward bias. Forward bias. So if BC junction is for reverse bias and BE junction is in forward bias, so it is said to be acting in the reverse bias in the active region. Active region means it acts as an amplifier. So here is the diagram. This represents the electron flow. So from here the electron flow will takes place. From here like this, like this, like this, like this, like this. At the resistor, the electron flow will be slowed down, and again it will be increased like this. It enters here, and it will make this negative more negative. So here, after that, this positive region will be converted to negative here. This will be cycle like this, and from here the negative region becomes positive because the negative region will become positive because the electrons will move from there. So there will be an empty space. Empty space is said to be as positive. So these are holes, and these are positive, and these are positive here. So this is about uh, electron movement and holes formation, and also the positive and negative charges on the BJT, polarities of the BJT in different configurations and different biases, in forward bias and reverse bias. What is about the base emitter junction, and why it should be in forward bias, and what is about the BC base collector junction, it is should be in reverse bias. So everything has been discussed in this video, and in next video we will understand about common collector characteristics, experiment lab experiment lab experiment circuit diagram. I will explain each and every part of the circuit diagram. So please let me know if you have any doubts, and please follow my channel for more interesting videos like this. Please subscribe to my channel, hit the like button, hit the bell icon, and activate the notification bar. Thanks for watching, friends. Bye.